Now, the other very, very important question that we want to answer is how many scatterings per second? Because if I can figure that out, I can pretty much figure out what the event or scattering or cross-section would be. So in order to figure out how many scatterings per second, I'm going to use another word. We need to answer this question. How many particles will have trajectories that will even have the chance of collision? So look at this picture. Imagine these are both neutral particles. What trajectory do you think that the incident particle has? And imagine this big particle is at rest. So you just have a big football and you're throwing golf balls at it. What trajectory should the golf ball have for the possibility of collision? I don't care if it's deflected or if it's bouncing back or whatever it's doing, but it is in the path where it will hit.
Can you answer the question?
So can you predict what the trajectory has to be in order for the little golf ball to hit the big ball?
Go down.
Actually, think about it this way. So this is a three-dimensional picture that I'm drawing in 2D. So these both spheres are three-dimensional pictures, right? If the incident particle is anywhere in this region, will it collide?
Yes.
Yes?
Yeah.
If it is here, let me do it. Like let's say the tiny ball is here, and it's going there. Will it collide?
No.
No, right? So that means it has to be in this circular area for the collision to occur. What's the area of a circle? Pi r squared. So what should the cross section technically be for this collision to happen?
Pi r squared.
What r?
The big R plus the little r.
There we go. The big R plus the little r, right? If it is even a little bit beyond that little r, will the collision happen? So the particle must be, I'm going to write this down, incident particle must be in surface area pi r plus rh squared for the impact to happen. Do we all agree with it? So that means I am going to define this as impact area, and I am going to redefine R plus RH as a new term called B, and I'm going to call it impact parameter. Fancy words, I know, but fundamentally they're simple. So the impact area is just the area where the two balls will collide. Impact parameter is the radius where the collision will happen. This is called impact parameter. Okay, so B is now called impact parameter. Okay, but we haven't actually answered our original question. We've just redefined a few things. So in order to find out how many scatterings per second, I'm going to make you do something that we've done a bunch of times. Collisions. We actually also did that in fluids. Okay, so I'm going to ask you something interesting. In time delta t, one particle moves distance delta x. What is delta x? Speed times delta t, if delta t is how I define it.
Yeah.
We've done it in fluids, we've done it a bunch of times, right? Okay, so then may I ask if this statement is true? In 1 second, a particle must be in cylindrical tunnel. Think of this as a tunnel that goes through that. Any particle in this tunnel will go and hit the football. Okay? So imagine, when you're imagining this, think of it as a cylindrical volume that goes and hits, right? Any particle in this cylindrical volume will go and hit it, the target. Okay? So we're going to call it the tunnel. I think it's also in the textbook. So we just named it that. So it's forever being known as tunnel. Okay, so in 1 second, a particle must be in the cylindrical tunnel to hit or impact. So then may I define that cylindrical tunnel as the pi r plus rh squared times delta x. Yes? What is the volume of a cylinder? Pi r squared h? Yes? Is my h delta x? Is my surface pi r squared? And that tunnel is going through, correct? Okay, so then may I replace this here? So then may I rewrite this as pi r plus rh squared v delta t? And we said 1 second, so delta t is 1. May I replace that as 1? I also have to do, so remember I said this is always going to be a beam, not a single particle. How do you want to define the beam? Can I call them n particles in the beam? So then for n particles, may I rewrite this as n pi r plus rh squared v? So here's my answer to the original question. This is the number of scatterings per second. So now if you didn't have all the math background at the beginning and you looked at this equation, it looks really scary, doesn't it? Lots of symbols and stuff. But fundamentally it is not. Just have to develop it so it doesn't seem scary.